Hi, my name is Glenn Silverberg, and I'm a senior developer at Prolifics. For many years, I've been involved in developing and improving Panther, as well as its predecessor, JAM. Here at Prolifics, we're committed to ensuring that our Panther and JAM customers can enjoy these great products for many years to come. To that end, we are developing a series of informative videos that will show you how to integrate your current Panther or JAM applications with today's modern technologies, extending their value. We will also explore future Panther enhancements that will serve to add additional integration capabilities. The first in this series is titled Build Restful Web Services from Existing Panther or JAM Artifacts. We hope you find it informative and would appreciate any feedback. If you already have a JAM or Panther application, you may want to expose some of its functionality to a non-Panther web application. For example, you might use a Panther application's JPL procedure that searches for a part or other item in your inventory. You can expose this functionality as a RESTful web service that can be seamlessly integrated into your non-Panther web application for processing orders. I'm going to show you how you can do that. What is REST and why a RESTful web service? REST, or Representational State Transfer, is a style of software architecture. It is often used as a lightweight alternative to a traditional web services implementation. It does not use SOAP or WSDL, making it simpler to use. It is also easier to maintain a RESTful web application. The lack of a well-defined service contract often allows for services to be augmented without the need to change existing clients. When used on the web, REST uses the HTTP methods GET, PUT, POST, DELETE, etc., and maps them to the CRUD operations, create, read, update, and delete. These are the operations one uses with a back-end resource, such as a database. When using the RESTful style, you access the web-based resource in a similar manner as you would access a database. A RESTful URI typically ends in a noun rather than a verb. Conceptually, one may think of a RESTful URI as referring to a table, and an HTTP GET operation on that URI will retrieve all the records in that table, append an item ID to the URL, and retrieve the single record associated with just that item ID. The data is typically returned as either JSON, which stands for JavaScript Object Notation, or XML. Web browsers can make these RESTful requests and update portions of a web page without the need to refresh the entire page. This is known as AJAX, or Asynchronous JavaScript and XML. Here's the architecture of the VidStore sample application. This is a traditional client-server desktop application where the server is the database engine. Now I'll show you what we're aiming for. We'll have a web-based application where Panther runs non-visual components in a Java native library on a remote server. Notice that the gray box showing the Panther runtime has now shifted from the client side to the server side. For our demo, we'll be using our Java native library within the JAX-RS runtime that comes with WebSphere Application Server version 8.0. JAX-RS stands for Java API for Restful Web Services, and it is defined by a specification for which there are several available implementations. WebSphere's implementation is based on Apache Wink. For your RESTful Panther application, you can use Apache Tomcat with Wink instead of WebSphere Application Server. Wink needs only a servlet container, not an EJB container. Let me show you the functionality we're going to expose on the web. This sample was written long ago, so it has the notion that a customer in a video rental store would use it to search for a movie to rent. Only an employee of the store would log in order to check out or check in movies for the customer. The search screen can return all movies available by simply clicking the search button. Or you can enter search criteria at the top. So for example, if I type A in the title field, it will return only movie titles beginning with the letter A. From the returned list of movies, we can select one, and the detail screen appears with further information about the selected movie. This is the bit of functionality we're going to work with. We have two screens, a master screen and a detail screen, and there is one method on each screen that we're going to expose on the web. We're not going to make use of the user interface you see here. We're going to completely redo the UI in HTML and JavaScript using a JavaScript package called jQuery. This VidStore application is actually running in test mode of the Panther editor. I'm going to go ahead and open the search screen in edit mode. The Panther editor can work with things called service components as well as screens. In the properties window, I'm going to change the screen type to component. The background of the screen has now changed to indicate that we are now working with a service component rather than a UI screen. We will still see all of the visual elements that are no longer needed for a non-visual component. This is simply a convenience for editing the component. The function that performs the search is shown in this control string attached to the search push button. The function is called vidSearch. The implementation of the function is located here in the screen level JPL module. Next, I'm going to open the Panther editor's component interface window, and I'm going to add the vidSearch method and select the fields that are needed as input and output arguments. Only methods shown here will be callable from outside of Panther. Also, the order of the parameter names is important. Arguments are passed to the method by position and returned by position, not by name. Next, I'll click on Template to copy a template of the JPL procedure we've just described into the clipboard. But I already have an existing vidSearch method in the screen JPL module. I'll paste the new template above it. I really only need the receiveArgs and returnArgs function calls from the template at the beginning and end of my existing procedure. The receiveArgs is going to populate the search criteria fields, and returnArgs is going to return the data that is in the grid. So I'll go ahead and just move those lines into my existing procedure and delete the rest of the template I just pasted. Our vidSearch function uses the Panther Transaction Manager's view command to select data into the grid. In your application, you may have an SQL select statement instead. It makes no difference what technique we use to retrieve the data, so long as we've gotten the data into the fields we're returning by the time we reach the returnArgs call at the end of the function. Next, we'll connect to the database on screen entry and close the connection on screen exit. I've already written the JPL functions to do that and placed them in a JPL file module that I'll public. There could be multiple users performing the search service at the same time. Each will use a separate thread of execution on the server and will require separate instances of the vidSearch screen to be opened, so each instance will need its own database connection. Finally, I'll save the component in the Panther library server.lib. I don't want to overwrite the original screen that is in videobiz.lib, and I'll need server.lib for my Panther server runtime. I'll cancel out of this screen since we're not building a COM object. Panther supports the use of service components for several types of server technologies, including EJB, COM, and Tuxedo. Everything I've shown you so far is applicable for any of those technologies. However, for our Restful Web Services implementation, we're going to use a Panther technology preview package for REST. If we find that there is sufficient interest in this technology from our customer base, we'll continue working to develop this into a finished product. I have Rational Application Developer version 8.0.4 running on my laptop, and it's configured to publish my VidStore web project to a remote server running on WebSphere Application Server version 8.0. I have my server.lib in the working directory for the app server, and I also have a panther.ini file there. This is exactly the same configuration used for Panther EJBs. If you're starting from scratch, you can create a new dynamic web project within RAD 8.0.4, and for the configuration, select IBM JAX RS configuration. This will ensure that your project includes the required libraries for JAX RS support, and it will configure your deployment descriptor to use IBM's JAX RS servlet. The topmost Java package shown here contains the classes that are specific to this VidStore application. Video Search is the resource class. It contains the methods that will be called by JAX RS for their associated URIs. Video List and Video Detail are bean classes that we'll use to pass data back and forth to the Panther framework. VidStore Demo Application identifies the classes we'll be using for non-JAX RS aware servlet containers. And finally, VidStore Message Body Writer will write out the XML or JSON to be returned to the web browser for the Video List and Video Detail bean. Here in the Video Search class, you can see that the @path annotation specifies that a URI ending in Video List following the context root will be used for this resource. The HTTP GET request will invoke this vidSearch method. The query parameters for vidSearch are the search criteria fields. Here we populate the corresponding members of our Video List bean. In the body of the method, we use the API for the Panther technology preview to open the vidSearch Panther component, call its vidSearch method, and close the component. We also have here a method named Detail, which is invoked when the title ID is appended to the URI after vidlist, and the title ID is then passed to the Detail method as an argument. The code for this method is similar to the other, except that it opens our other Panther component and calls a method in that component. Let me show you in the REST client from WizTools how we can call these methods and get back JSON or XML. Here we are making a GET request for the list of videos whose title begins with the word star. Three videos were returned. To get a bit fancier, we've written a demo client using HTML and jQuery that makes our RESTful requests and looks something like the original Panther UI. The client files are located in the web content folder of my web project. Here's what it looks like. Please contact us and let us know if you're interested in using REST on the web with your Panther or JAM application. We'll be happy to answer any questions you may have.